We already know that if the distribution is binomial, when n multiplied by p is greater than or equal to 5, and n multiplied by 1 minus p is greater than or equal to 5, then this distribution will become very similar to normal distribution.
Okay.
And a lot of times we have incentive to use normal distribution instead of binomial distribution. So it's basically something nice that is happening, especially for you who now understand normal distribution and you have educated yourself with normal. You would like to switch from combination of R out of N and so forth to just finding an area in the table. So look at this question. The probability, it's very similar to a question that I have already practiced with you. The probability of a sick patient is like a specific sickness, okay, is 0.05. What is the, 10 people are in the waiting room. What is the chance that at least 5 are sick? Okay. So when you look at this question is a binomial question or is a normal question?
Sick or not sick?
Yeah, very good. It's like a kind of true, false. That was item 4. What else?
Agree, not agree?
Yeah, this is 6, not sick. That condition is satisfied. 4 conditions must be satisfied if you want to argue that it is a binomial distribution. Is this binomial or normal question?
Binomial.
You are arguing for binomial. Okay. What are the other things that tell you that it is binomial?
P is constant. We know
Very
N.
good. Yes, perfect. P is constant. What else?
We know N. We know R.
What is N?
10.
Very good.
R is
And we are interested in specific number of successes. In this case, we are interested in R equal to, what will make us happy? Will 0 make us happy? 0 sick people.
no.
No.
1.
Is it 5?
5 will make us happy. Yes.
6,
6.
7, 8, 9, 10.
And 10. And then you may think to yourself, oh, this is a lot of binomial. How about I do what will make me unhappy? That would be 0, 1, 2, 3, 4. Right? And that is 5 binomials. So it's a lot of binomials to work on. So when this happens, then, and this example is actually not that big, like the number of patients waiting could be 40, okay? So you think to yourself, okay, Amir is telling me, and everybody is telling you, that if these 2 conditions are satisfied, then instead of using binomial, after this, you will write down in your exam, this question is in fact binomial. But then you think to yourself, is it possible for me to answer this question instead of binomial with normal? And then you think, okay, if that's true, NP must be greater than or equal to 5. N is 10, P is 0.05. So NP is what?
0.50? Yeah.
0.5.
0.50?
Oh, 0.5.
0.5.
Yeah.
0.5. It is not greater than then. So you see, 0.5 is not, it is less than 5. Therefore, we have to do binomial, right? You have to answer this question with binomial. Now, let's see what happens if the number of patients sitting there is 40. Okay, so there are 40 people in the waiting room now. And we want to know what is the chance that at least 5 are sick. So this set of things that we want goes up to 40. And the set of what we don't want is still 0, 1, 2, 3, 4. And we have to do 5 binomials. NP in this case is, N is 40 multiplied by 0.05. What is the result? 2. So is it bigger than or equal to 5?
No.
No. In this case, it is not less than or equal to, it is less than 5. Therefore, we have to do binomial. And if you have to do binomial, of course, you will do 1 minus this. We have practiced it, right?
Yes.
Because we are not going to do 40 binomials. You will do 1 minus these 5 binomials. You remember that. You have to check these 2 conditions. You cannot simply decide that I'm going to answer this question that is binomial with normal distribution. Okay, you have to check the 2 conditions. Now, let's say that the probability of sickness changes from 0.05 to 0.15. Now, it is still a constant P. The number of experiments is 40. What will make us happy is from 5 to 40. What will make us unhappy is those 5. Let's try if NP will allow me to go to normal. 1.5 multiplied by 40.
6.
Please tell me the result.
6.
6.
6. Is 6 greater than or equal to 5?
Yes.
Yes.
Okay. So can we use normal?
Yes.
Can I use normal distribution instead of binomial now?
Yes.
Yes.
Ladies and gentlemen, can I use normal instead of binomial?
Yes.
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 Okay, I will give an Amir dollar to the first person who says no.
No,
Why? Why no?
because it's binomial.
No. Yes, in some when 2 conditions are satisfied, we
Yes.
can use.
Yeah. If you do like n times 1 minus p, yeah.
Yeah, okay. 2 conditions must be satisfied, not 1 condition. So we have to now find n multiplied by 1 minus p. So 1 minus p is 0.85 multiplied by 40. Okay.
34.
Sorry?
34.
34. Is it greater than or equal to 5?
Yes.
Very good. So both conditions are satisfied. Then you will say, therefore, I am allowed to use normal approximation to binomial. Notice that we know, and we are emphasizing that we know, we are intelligent, that this is actually a binomial distribution. But because we are allowed to, and it would be easier to answer the question using normal, we are answering with normal distribution, okay? So now all of that effort was to identify whether or not we can use a normal distribution as an approximation to binomial. I will extend the space here. So I can, you need to draw a very detailed normal distribution. That's why I want the curve to be big, okay? So this, if I'm going to use a normal approximation to that binomial distribution, what should be the mean? Notice that the normal distribution, we have to annotate it with 4 points. One is that this is normal. Second, that we have to identify what is being distributed. This is the probability of sick people among those 40. So these are the 4 items that I just tested you, because I didn't want to talk to people who don't understand what we're talking about. So what would be the mean of a normal distribution that would be similar to this binomial distribution?
6.
Why do you say 6?
Because n into p is the mean.
The mean, very good. So you argue that my normal distribution should have a mean that is similar to the mean of the binomial distribution. The mean of the binomial the mean of my binomial distribution was NP, which is 6. Okay. What should be the standard deviation of this normal distribution?
34.
It should be the standard deviation of my binomial distribution, because I'm
So
using
square
this
root.
normal distribution instead of a binomial distribution. So it should be n multiplied by p multiplied by 1 minus p. It should be 40 multiplied by 0.15 multiplied by 0.85, and then we get the square root. So can you tell me, please, what is the standard deviation of that binomial distribution?
So yeah, 2.2583.
Very good. So this is the standard deviation of the binomial distribution. Of course, if I'm using a normal distribution to approximate that binomial distribution, it must have the same standard deviation, right? Now, this is obvious. Obviously, the normal distribution that I'm using should have similar characteristics of the binomial distribution. The only tricky point here is that, okay, the question says at least 5. So the point of interest is 5, right? Let's say this is 5. And if it is at least 5, so it means more than 5, right? So what we would usually do is that we would hatch this area. So it'd say the area of interest is anything more than 5. Notice that I start from very far. This is what you have to do from now on, because it's very sensitive. This is all of those points that are more than 5, they will make me happy, right? All of these will make me happy. And then when I'm getting close to that 5, I think to myself, okay, do I have to, is this really a normal distribution we are dealing with? No, it's not really a normal distribution. It's in fact a binomial distribution. So in binomial, it's a discrete probability distribution. So the column that shows the probability of 5 is a column like this. The column that shows the probability of 6 is a column like this. Now, we are using an approximation, which is this. This is the column for 4, and so forth. So the question is, should I include that column above 5 or not? Let's read the question again. At least 5 or 6. So that means 5 or more than 5. So are we really interested in that column above 5?
Half of it, yeah.
Why half of it?
Because it says 5 or more than 5, right? So,
Yeah, so 5 must be included. Why do you want to include half of 5?
so full of the full
The whole 5, right? So when we are doing this normal approximation, we actually don't stop at 5 and we cover the column above 5 because we know that this is actually what we want. We are just using the normal approximation to what we want. So although the question says the point of interest is 5, but we know that this whole column should be included. Therefore, our point of interest is not really 5. It is this boundary of the area is, it's not 5, it's between 4 and 5. Yeah, it is 4.5. Very good.
So do we go till 4.5?
Yeah, as you noticed, I crossed that 5 boundary and I covered the whole column of 5.
Yeah, that is why I was
Yeah,
confused.
the rest is easy. Now we want to find this area. Of course, we have to find the Z for this point. Z is 4.5 minus 6 divided by 2.2583. Please help me. Yeah, I have a question for you. Let's think about 4.
Yeah.
Okay?
Yeah.
Got this 4. 4 is this column.
Yeah.
Do you know why 4 is this column, but not half of this column? Okay. What is the distribution we are dealing with?
It's normal distribution.
No, that's the point. It is not normal. Okay.
It's okay.
What is the distribution we are dealing with?
Binomial?
It is
Binomial.
binomial. We are just using a normal approximation. The fact that we are using normal approximation doesn't allow us, if we want this column 5, just because we want to use normal, then we use half of it. It doesn't allow us to do that.
Okay.
Okay. So just every time that you're doing a normal approximation to binomial, don't forget that it is binomial. So you have to think, are you including that column? You cannot include or exclude half of a column.
Okay.
Yeah. Okay. So please tell me that.
So 0.
That was a really good question. That's the whole trick here. Yes?
Minus 0.66.
Just that's it?
Do you want more? Okay, so
I want 4.
6642. 42, yeah.
Very good. So now please go to the table and find Z equal to 0.66. If you find Z equal to 0.66, that gives us this.
0.2454.
How much?
0.2454.
2454. And then how much is this area?
0.5.
0.5. Therefore, the answer to the question
0.7454.
is 0.2454 plus 0.5. Good. Now that you got the whole concept, you will start benefiting from this. Now, look at this. Let's another harder question. And you will see how
Amir?
easy. Yes.
Sorry, I had a quick question before we move on. When do you know like when to add and then when to subtract?
So look at this blue area.
Yeah.
This do we like the whole thing? Yeah,
Yes.
I want all of that,
Yeah.
and I want all of this. So why should I subtract?
Okay, that makes more sense. Okay,
Yeah,
thank you.
so yeah. Okay.
Okay.
So notice that I never ask you to memorize any rule. It's everything is absolutely obvious. And the more that we practice, the more you will see that. So
Okay,
the same
thank you.
scenario, there is a hospital and blah, blah. Now I ask you, and there are 40 patients and so forth, what is the chance that more than 10 people in the waiting room are sick? Okay. So
more than 10?
again, I ask you, what is the distribution?
Binomial?
Yeah, just for remembering it, obviously we answered that before. Distribution is binomial, and we know its mean and it's a standard deviation. And what will make me happy, what I'm searching for, is more than 10 people. So will 10 make me happy?
No.
11?
Yes.
11, 12,
240.
up to 40 will
40.
make me happy. What will make me unhappy would be 0 to 10. Both of them are painful. So I have an incentive to switch to normal distribution, although it is binomial. NP is 6. N multiplied by 1 minus P is what? 34. Both conditions are satisfied. I will use normal. Okay, I'm just, although we already did it, I'm just showing you all of the steps. What kind of normal distribution I'm going to use? A normal distribution whose mean
It's 6.
yeah, whose mean is 6, whose standard deviation is
2.2583.
0.25,
2.2583.
2.2583.
83.
Okay, so this is the, I identified all of the 4 items for my normal distribution. That is the annotation part. The next step is that I have to identify the point of interest, 10, right? This is 10,
Yep.
and more than 10, okay? So if it is more than 10, first of all, this to remind myself that it shouldn't fool myself, this is not a really normal question. It's a binomial question. So this binomial, I'm interested in more than. So I start from positive infinity and I get close. And when I'm getting close to 10, then I think to myself, oh, Amir, this is not normal. Be careful. Should you include the 10 or not? Should I include the 10 or not?
In this case, no, because you're looking for more than 10.
More than 10. So I have to stop, and I'm not going to include any part of that 10. So what is my real boundary?
10.5.
10.5 to infinity.
10.5. Very good. And the Z for 10.5 will be 10.5 minus 6 divided by 2.2583. Therefore, Z of interest is
1.9926.
1.9926. Okay. So now we want this area for Z more than 1.9926, the real boundary. Okay. So this Z is 1.9926. Can we find this blue area in the table?
Yes.
Yes.
No, we cannot. the table in the book only gives us the areas between the mean and a point. So we only can find this area in the table. So please go to the table, find the closest number for Z is, I think the closest number, we have 1.99 and we have 2. 1.99 is closer. So tell me, what is this area?
Is
0.4767.
0.
4767.
For 1.99, are you sure?
I think. Yes.
Okay, very good. So now to find the blue area, like one of your classmates asked me, how can we find this blue area? This is now the time that we'll think, okay, from here to infinity is 0.5. If I subtract this green area from 0.5, then I will get the blue area. That is why I subtract. So the blue area, or the answer, would be 0.5 minus the green area, which is 0.4767. And the final answer is
0.023.
0.02.
No. Yeah. No. Sorry. 0.0233.
Thank you very much. Okay. So because I always want to show you all the possible questions, and now, you know, for the next question, I'm not going to go through all of this process. Of course, we identify that it is binomial. We check the 2 conditions that must be satisfied and so forth. But to do it faster, this time we will answer it in a more concise form. I ask you, what is the chance that the number of patients are less than 9 at least 4 and less than 9. So this is in the English form. When we translate it to symbolic form, would be x at least 4. What does that mean? It means that more than or equal to 4 and less than 9. At least 4 and less than 9. Okay? So all of the things that we said above are now okay. Let's do some substantive work. So you go through all of that process and you know that it's a binomial distribution. We will use the normal distribution that is similar to that binomial distribution. The only thing that is different now is the points of interest. So what are the points of interest in this case? One is 4 and the other is 9. Now, I have a question for you. If it was really a normal distribution, would it matter if we include 4 or not?
No.
No, because the chance of 4 would be 0. But this is not a really normal distribution. It's a normal approximation to a binomial distribution. So it matters that on this side we have less than or equal, and on this side we have less than. So let's think about this. There is a column above this, and there is a column above 9. And now that I want between these two, I would start my hashing from the center. Okay. Now that I'm hashing from the center, when I get close to each one of these 2 columns, I become nervous. Should I include 9?
No.
no.
How about I include half of it?
No.
No? Not even half of it?
No.
Okay,
No.
good. Then I go to this side. Should I include 4?
Yes.
Yes.
How about I just include half of it
No.
No.
for fun? Should I include half of it or all of it?
All of it.
it.
Yes, of
All?
course. Because, yes, of course. And then I think about my boundaries. The gentleman who didn't have a pencil, go and buy a pencil. Colored pencil at $1.25. Okay. So what is this point?
8.5.
8.5. And what is this boundary of the area of interest?
3.5.
3.5. Very good. Of course, we are not really interested in those numbers. Chebyshev said that the distances should be measured in the form of how many standard deviations they are away. Please tell me the Z for 8.5.
8.5
Yeah, 8.5 minus 6.
1.1070.
1.1070. And what is the Z for 3.5?
minus 1.1070.
Really?
Yeah.
1.1070.
Oh, beautiful. So these two areas are identical, right?
You're missing one. It's 1.10. Yeah.
These two areas, thank you. These two areas are the same, right? Because this point and this point are the same distance to the center.
Yes.
So go to the normal distribution and just simply find Z of 1.107. Of course, we don't have 1.107. The closest would be
1.11.
Yes.
It's
So the blue area is
it's
between mean and 1.11.
0.3665.
And this one,
The same.
and the total, the answer would be
0.7330.